The typical vapor compression refrigeration system can be divided into two pressures: condensing or high side and evaporating or low side. These pressures are separated in the system by the compressor and the metering device. Condensing pressure is also referred to as high side pressure, head pressure, or discharge pressure. The condensing pressure is the pressure at which a refrigerant changes state from a vapor to a liquid. This phase change is referred to as condensation. Line and valve friction and the weight of the liquid refrigerant can cause pressure drops along the high side of a system. On a small system, the condensing pressure can be read directly from a pressure gauge connected anywhere between the compressor discharge valve and the entrance to the metering device, because the pressure drops are so slight. On larger systems, if a true condensing pressure is needed, the pressure must be measured as close to the condenser as possible. Evaporating pressure is also referred to as low side pressure, suction pressure, or back pressure. The evaporating pressure is the pressure at which a refrigerant changes state from a liquid to a vapor. This phase change is referred to as evaporation or vaporizing. A pressure gauge placed anywhere between the metering device outlet and the compressor, including the compressor crankcase, will read the evaporating pressure. Again, there will be line and valve pressure drops as the refrigerant travels through the evaporator and suction line. The technician must measure the pressure as close to the evaporator as possible to get a true evaporating pressure. On small systems where pressure drops are slight, this pressure is usually measured near the compressor. Any substance can be in one of three states: solid, liquid, or vapor. Modern refrigerants exist either in the vapor or liquid state. Refrigerants have such low freezing points that they are rarely in the frozen or solid state. Both the evaporator and condenser of a refrigeration system can contain liquid and vapor refrigerants simultaneously if the system is operating properly. Refrigerants can be in one of these conditions: saturated, superheated, or subcooled. A refrigerant in the vapor state can be in the saturated or superheated condition. A refrigerant in the liquid state can be in the saturated or subcooled condition. Vapor pressure is the pressure exerted on a saturated liquid. Anytime saturated liquid and vapor are together, as in the condenser and evaporator, vapor pressure is generated. Vapor pressure acts equally in all directions and affects the entire low or high side of a refrigeration system. All refrigerants have different vapor pressures, and it is vapor pressure that is measured with a gauge. Saturation is usually defined as a temperature, although saturation temperatures vary depending on the pressure that the refrigerant is under. The saturation temperature is the temperature at which a substance changes from liquid to vapor or vapor to liquid. Liquid at saturation temperature is called saturated liquid and is at its maximum temperature for that pressure. Vapor at saturation temperature is called saturated vapor and is at its minimum temperature for that pressure. However, both liquid and vapor are at the same temperature for a given pressure when saturation occurs. If one attempts to raise the temperature of a saturated liquid above its saturation temperature, vaporization of the liquid will occur. If one attempts to lower the temperature of a saturated vapor below its saturation temperature, condensation will occur. Latent heat is the heat energy that causes a substance to change state without changing the temperature of the substance. Vaporization and condensation are examples of a latent heat process. Sensible heat is the heat energy that causes a change in the temperature of a substance. The heat energy that superheats vapor and increases its temperature is sensible heat energy. The heat energy that is rejected by subcooled liquid, lowering its temperature, is sensible heat energy. Only vapor can be superheated. A superheated vapor is any vapor that is above its saturation temperature for a given pressure. In order for vapor to be superheated, it must have reached its 100% saturated vapor point with no liquid remaining. The addition of heat causes the vapor to increase in temperature and gain sensible heat. Sensible heat is the heat energy that causes a change in the temperature of a substance. Superheated vapor is present in the evaporator, suction line, and compressor of a system. Only liquid can be subcooled. A subcooled liquid is any liquid at a temperature below its saturation temperature for a given pressure. Once all of the vapor changes state to 100% saturated liquid, further removal of heat will cause the liquid to drop in temperature and lose sensible heat. Subcooled liquid is present in the condenser and liquid line of a system. Another method of subcooling liquid, called liquid pressure amplification, is covered in the section on superheating and subcooling. This method increases the pressure on subcooled liquid, causing it to be subcooled even more. This creates a liquid with a temperature below its new saturation temperature for the new higher pressure. Technically, subcooling is defined as the difference between the measured liquid temperature and the liquid saturation temperature at a given pressure. Likewise, superheating is defined as the difference between the measured vapor temperature and the vapor saturation temperature at a given pressure. Systematic troubleshooting requires mastering the function of all refrigeration system components. It is also important to be able to recognize the pressure, state, and condition of the working refrigerant in the system. Click on the tabs or each highlighted point in the refrigeration system diagram shown here to learn more about the pressure, state, and condition of the refrigerant at that point.